What's up guys, I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. In this video we are going to tackle, data science interview questions 33 up to 39. So without any further ado, let's get straight into it. So we have data science interview question number 33. Which programming language do you prefer for text analytics, Python or R? So this answer is subject to variations. When you are answering this question in your interview, it is good to know that this is something that takes into account your personal preference. Okay, so if you are more familiar with R, or if you just prefer R to use, when it comes to text analytics, you go ahead and you can explain that. Now, the answer that I sourced is actually Python. Okay, Python is the ideal option, and also because of the fact that you guys know Python is the most popular programming language at this point in time, and because of its capability, pandas package and NLP package, they both provide simple data structures and high performance data analysis capabilities. So again, you guys can answer Python or R depending on preference. Personally speaking, I have text analytics experience, NLP and so on. I have experience in Python and it is really interesting. It's really powerful. So that's what we have there. For data science interview question number 34, we have, can you explain the term logistic regression? So the technique of logistic regression, often known as the logit model, is used to predict a binary outcome from a linear combination of predictor variables. For instance, suppose you want to predict if a certain political leader would win or lose an election. The outcome of the forecast is binary in this case, that is 0 or 1, win or lose. The amount of money spent on election campaigning by a particular candidate, the amount of time spent campaigning, and so on would be the predictor variables in this case. So that is a simple explanation of logistic regression. Even if you just tell the interviewer that it is a widely used binary classification algorithm, yeah, that would be accepted as well. So that is that. The simpler the better. Okay, that's my personal opinion. So data science interview question number 35. What are recommender systems and how do they work? So we have covered something similar like this in a previous video, but basically a recommendation or recommender system is basically a subclass of information filtering systems that are designed to forecast a user's preferences or ratings for a product. Movies, news, research articles, products, social tags, and music all employ recommender systems. So that is fine. Now, question number 36. Why is data cleaning so important in analysis? Now, this question is relatively open-ended, guys. You can explain and provide explanations for any, based off your personal experiences. So if you are, seeking a data analysis or data scientist role, you can use your personal preference and experiences to actually explain this concept. Okay, the importance of data cleansing for data analysis. So cleaning data comes from cleaning data from multiple sources in order to convert it into a format that data analysts or data scientists can work with is a very time-consuming process, because as the number of data sources grows, the time it takes to clean the data grows exponentially due to the number of sources and the volume of data generated in these sources. Cleaning data can take up to 80% of the time, making it a crucial part of the analytical process. So with regards to the process of data cleansing, so I have come across several sources, and all these sources mentioned one kind of uniform explanation, or I don't know, just like a sort of trend that was observed. And it says that in the field of data science, it actually said that 80% of the work of a data scientist is actually, has to do with cleaning data, and the other 20% has to do with those predictions and machine learning sort of model making and so on. And that is totally correct, right? When it comes to data science, it's as the name implies, the name of the field or the domain itself, data science, it has to do with finding ways, as many as we can. All these ways and techniques and methods have to do with perfecting data for the next phase. Now you see, data science itself is a kind of technology stack. Okay, data science falls somewhere in the middle, I would say, because how we actually learned this back in 2020 was that data, so these are the important portions of that tech stack. You have data analysts, that's the first level, the bottom of the pyramid. One up, you have data scientists, that's why it is at the middle. And one up, you have machine learning. So those are the three important, tech fields or domains that actually make up a kind of full stack data scientist. So that's what we have there. Now, for data science interview question number 37, we have what makes cluster and systematic sampling different. So when it becomes impossible to investigate a target population that is spread out over a large area and simple random sampling is not possible, cluster sampling is used. A cluster sample is a probability sample in which each sampling unit is a group of items or clusters. A statistical procedure in which elements are chosen from an ordered sample frame is known as systematic sampling. The list proceeds in a cyclical fashion in systematic sampling, so whenever you reach the end of the list, it is started over from the beginning. The equal probability approach is the best example of systematic sampling. Okay, so that is what we have there. Now, data science interview question number 38. Is there a difference between expected value and mean value? The concepts are not different, but they are used in different contexts. Okay, when discussing a probability distribution or sample population, the term mean is used, whereas expected value is used when discussing a random variable. For data sampling, the sole value derived from the sampling data is the mean value, the mean of all the means, or the value derived from several samples is the expected value. The population mean is the expected value. For the purpose of distribution, under the condition that the distribution is in the same population, the mean value and expected value are the same regardless of the distribution. So that is not difficult to understand. These explanations are very clear and concise. Now on to data science interview question number 39. What does the p-value mean in terms of statistical data? Okay, what does the p-value mean in terms of statistical data? Now, in statistics, the p-value is used to quantify the importance of data after a hypothesis test. The p-value, which is usually between 0 and 1, aids readers in drawing conclusions. A p-value of more than 0.05 indicates that there is insufficient evidence to reject the null hypothesis. A p-value of 0.05 indicates that there is a substantial amount of evidence against the null hypothesis, implying that it can be discarded. Next we have the marginal value p-value is equals to 0.05 indicates that the result may go either way. So that is what we have there, guys. That's all for this video. Thanks so much for watching. Thanks for staying till the end of the video. Good luck with your work, and I will see you in the next YouTube video.